Welcome back, dear friends. Now, thank you to all of you who responded to my last video where I was asking whether you'd like me to get on with the wretched steampunk arcade machine or the lovely Art Deco clock that I started building 30 years ago. It's about half and half, the responses. Half of you who love Art Deco wanted me to get on with the lovely Art Deco clock, and the other half who like to see me struggling, flailing around, banging my head against the wall and generally getting frustrated, wanted me to get on with the arcade machine. So what I decided to do is I'm going to do both. I'm going to have a go at the arcade machine until the head-shaped dents in the wall are too prevalent, and then I'll go on to work on the island of tranquility that is this Art Deco clock, and then I can swap yin and yang if you like. So that's the plan. So the first thing to do is to learn how to use programmable LED strips, which have nothing to do with either, but it's something I don't know about. And I was contacted recently by Ben, the dinosaur man, who runs Jurassic Jabber, an organisation that goes into kindergarten schools in the US and instills the love of paleontology to the students, the young people, which is lovely. And if you remember, last year I'd started working on the time machine, because Ben goes into schools with lots of 3D printed fossils and all sorts of other amazing things. And he bought a 1950s radio, wooden radio enclosure cabinet, because he wanted to create a time machine so the kids could go up and choose a particular era of paleontology, set it and have some effects, sound effects and things like that, and then be transported, if you will, to that era. And there were two panels. Let me show you. There's the design, and it's so exciting when you turn that into that. So this is the front of it, obviously, with the reflection. Hang on. Without the reflection, you turn there all the different eras around here, and you'll turn this. We can hear the pinking of the reed switches. Yes. So kids can set that up, and then they need to engage the engine or something. Again, Ben told me all the different things he wanted, and then there are two key switches that they have to turn. And I managed to get all these wired up in a particular order so that without any logic, just using the switches, so that the kids had to go through and set everything in the right way. So that's the top bit. Oh, and I was wittering on, saying that I decided to do it this way rather than using a teensy and a teensy soundboard and all that, because I would have spent hours faffing about getting all that working. Buying an off-the-shelf one, it just worked for me, and using reed switches, because there's quite a limited budget for this. So there's the first one. Right, let's go and have a look at the design for the lower panel, the new one. So here's a picture that Ben put together showing his idea. It's nice because it's always lovely working with a customer who's got a good idea of what they want. He was quite distinct about this, the different colours. There's an artifact, some sort of 3D printed artifact like you'd find in Tomb Raider or something, that the kids have to turn, moves the lines of colour across. When they reach this end, this will illuminate somehow and indicate that time travel is happening. That's most exciting. I'm not going to design or print these two because, as I say, the cost constraints, and Ben's really good at printing dinosaur fossils, so he's quite happy to do those two bits. I've got to work out this bit. Now, I did think about possibly wiring up LEDs manually, well, by hand, individually, to some sort of switching device. No. And having done some research on things, because I've never used anything like this before, programmable LEDs. So there's his design with some dimensions on, just to confirm what he wanted. And there's the drawing that I did on the CAD 2D design, so I can get everything laid out and worked out how to make it from different layers. Sent that to him. He was happy with the dimensions and everything. So what I did last night was to work out how to actually construct this so that we can house these LEDs, the programmable ones, within this with layers of acrylic. This one will be the top layer, made of 3mm painted, brass painted acrylic, with the red bits being little twiddly engravings. The next one will be, oh yes, this is going to be 2mm black acrylic, of which I have just enough. Because the problem is, if you have painted clear acrylic, light still shines through it. Really easily. It's very obvious, which is a pain, because I don't want light shining out all over the place. I just want it to illuminate these strips. So a sheet of black acrylic next. Yeah, light shining through was even a problem on the climatic revelator, because the light's shining up from inside here, bouncing off a mirror, and you could see it lighting up. You could actually see it through this front bit. So I had to spray that black on the inside to stop it. Oh yes! And the lamp on the Gregorian scribulator, that was shining through so much. So I've sprayed the inside around the little LED black as well to stop it shining through. So it's quite a big effect. Then 5mm thick sheet with the slots to hold the LED strips. And then it's all going to be sitting on some plywood that will stain up the back. And rather than measuring things out with a ruler and pencil, how dare you, I'll just get the laser cutters to draw where I need to cut things out of. I'm going to transmit the light from the LEDs through to the front with some strips I'll cut out of white opaque plastic, so it just sort of blurs it a little bit. Talk about absence of production values, but let's talk LED programmable strips. As I said, I've never used these before, and they're absolutely amazing. You know how easily amazed I am, but they're phenomenal. I went to a shop called Pt1, which sells all sorts of exciting microprocessor controlled type stuff. Pt1 is a brilliant name because it's short for Pirate Monkey Ninja Robot, I think. Such a clever idea and memorable. And ordered the red, green, blue version. And there's a red, green and blue version. What I actually got was a red, green, blue, white version. I'm sure it was my mistake. Which did cause quite a few problems. We'll come on to that later. It's absolutely amazing. So each one of these LEDs has a red, green and blue LED, and then on the other side separate a warm white LED. The reason being that they're used now so often in sort of architectural lighting that you will want at some point the room to be lit properly white. Prior to the white ones being added, they just use red, green and blue on, some sort of mixture of them to try and simulate white, which never worked very well. It always looked a bit muddy. And you can cut them up, as with all these LED strips. They very handily come with little scissors sort of shapes and things with lines, so you could cut them up. Isn't that amazing? There's so much going on in that little chip. From power controlling the LEDs to different brightnesses, to handling all the data. It's absolutely phenomenal. So I got my LED strip, and at one end there was a female socket, and at the other there was a male plug. I don't know whether you could get male sockets in this day and age, even only knows. But it was handy because I could just poke the wire from the Arduino into it, the signal wire. And then these things have a black wire for 0 volts, a red wire for plus 5 volts, quite a lot of current, so it's important to run them off high power supply, and a signal wire. And I loaded the fast LED library for the Arduino, which was recommended, and spent a really frustrating hour trying to work out why it didn't work. I couldn't even get one LED to do anything. Nothing at all. And I thought, what ridiculous thing have you managed to do? What stupid, obvious thing. I thought, well, there's a connection at each end of this strip. Let's connect it to the male one with a crocodile clip and just check if that makes a difference. And it does. And it's interesting because it illustrates a couple of things. Now, I hasten to add I hadn't given it much thought about how programmable LEDs work. They are amazing though, and I just assumed stupidly that they worked by each having an individual address number, and then the data sent through, and when the particular address comes up with the values for the brightness of the LEDs, that will then operate that particular LED. Now that is stupid on so many levels. One, it would mean that every single LED on a strip, and this is the 60 LEDs on this one, but obviously you can get thousands of LEDs, would have to have an individually coded address. That's stupid. Two, if you had actually managed to do that, how would you connect up all these in the right order? You wouldn't be able to cut them or move them around or anything. Stupid. And then once I'd moved the wire to the right end, I then noticed that there were arrows pointing and little things on each LED saying DI for data in, D out for data out. And it dawned on me how these work. And it's so clever. And I'm sorry if this is teaching you to suck eggs, but just in case you're not aware, it was a manna from heaven when I realised what happens is the software that controls it, the sketch on the Arduino, creates a really long string of serial data. I know it's not a string, but you get the drift. And each LED is represented by 4 numbers in this case, red, green, blue and white, and one after another. So I reckon it sends it through to the first LED in the string, the row of them. That reads the first 4 digits, in effect, the brightness, and chops them off and passes it on. The next LED reads the first 4 things, chops them off, passes it on. It's such a clever way of doing it, because it means that you can have any length. That's amazing, and they don't all have to have individual addresses. It sort of acts a little bit like some sort of huge shift register, sort of, vaguely. So that's how it worked, and I was absolutely thrilled, because then I got it to do stuff. But, as always, not the right stuff. You live and learn, don't you? And hopefully this may prevent some of you from not having to learn too much. Fast LED library does not work with RGBW LEDs. It will only work with a huge variety, but only with red, green, blue programmable LEDs. It took me a long time to find out, because I was Googling it and stuff like that, and lots of people were saying, oh look, I've got a hack for this to make it work with white. It doesn't. So, on to library number 2. Library number 2 uses the Adafruit NeoPixel library. That works. Oh, the joy, I tell you. It's so exciting when you finally get it working, having not given up. I will connect it up and I'll show you what it does. By the way, this is one of the example sketches that comes with it. Oh, I tell you, the joy. So it fades up and down, and it's lovely, as always with these sketch examples, the library examples. They explain things so simply, so you can get an idea, fading the whole lot, then white up and down, and then running the different colours along. It's brilliant because it so clearly demonstrates what's achievable and how it can be done. I mean, it's just fantastic. I love it. So there's about 4 different patterns, but I mean, oh, look at the colours fading up and down. It's just incredible. And the fact that you can have loads of these, endless numbers, as long as you just have the right number of data. That's amazing. So having been filled with the joys of spring, and I have to say it is lovely weather this week, it's absolutely gorgeous, I thought I'd write just an experimental sketch to see whether a variable resistor potentiometer, as it's turned and read by one of the analog inputs on the Arduino, I could get it to do something interesting. And I thought I'd have like little white specks coming up, because obviously Ben wanted the green, purple, something or other, normal strips, but then as time travel approached, it could start having little white flickers. I got the idea because I remember watching the lovely film, I think it's a brilliant film, Sunshine, with Cillian Murphy in it, I don't want to have a spoiler or anything. Listen away if you don't want to know what happens at the end. But he's sitting in his huge spaceship surrounded by all the nuclear weapons on Earth, heading for the sun, and they start to detonate, and there's lots of little sparkles just in the air all round. Always remembered that, and I just thought it would be quite a nice sort of motif, shall we say, a particularly annoying phrase. So I'll show you that now. So my sketch just uses that library and the NeoPixel one, and reads the analogue output from the potentiometer. And just as this experiment, it was just sort of proof of concept. As it gets nearer the top, it starts using the random function on the Arduino, just starts randomly illuminating the white LEDs. So as I twist the potentiometer, look, just see, as you twist it further and further, you get more and more. Isn't that lovely? And the whites obviously are very much brighter, but I can fiddle with that. But just as a proof of concept, that's really nice. So once I've got this written, the colours can go across, the different colours, and then as you get closer, then it all starts, and then it can sweep across to illuminate that globe or whatever on the left hand side of the control panel. So that was really exciting. I just can't tell you how the potential of these programmable LEDs, and I know that you can get minute ones of 2.2¼ millimeters square or something. Oh, it's just amazing. It's so exciting. One wire to transmit all the data. Right, stop talking about that. I need to start working on the enclosure that I talked to you earlier about, the different layers. I'm going to get them cut out. Oh, and by the way, many apologies again for the delay. In the last video, I'd been spending days trying to burn 65 years worth of phone bills, electricity bills, correspondence, bank statements, you name it. My parents kept everything. Since then, my sister and I have been trying to find good homes for the 2,500 books that my mum had accrued. She loved reading, as did her parents as well, which she inherited their books. Very old ones, some of them, amazing. My sister and I have slowly brought them all downstairs and made piles of them, up to about your waist height. So 2,500 books looks like about 80 piles like that, all around down the stairs, around the walls. So we're slowly getting through it. So this is the 3mm thick top layer with the engravings. I haven't switched the laser cutter on for weeks. So I'm going to get ready with the stop button because the limit switches are broken. Stop! Oh dear. I've been bringing home all sorts of stuff that I found in my bedroom at home. This was something I remember making at secondary school. When I found I had some really thick card and thought, oh, I could stick it together. And then had a little pop of FX luminous paint, so painted the edges. Hopefully it was after the days of radioactive luminous paint. All these things that I need to find homes for. So that's now downloading or turning that DXF file into loads of G codes which are used to control the laser cutter. And I'm so pleased, because this is the last sheet of 3mm thick acrylic I've got. It's got all sorts of bits cut out. All the others are absolutely hopeless. There's virtually nothing left at all. They're just bits cut out. I don't know quite why I'm saving them. So I'm thrilled about that. Let's get cutting. Test to check we've got enough space of the plastic. Yeah. I do apologise, the state of this, the filth. Oh dear, oh dear. Oh look, dear friends, it's so exciting. I can't tell you. All my creative juices are flowing, It's amazing. Oh, I'm so motivated to be getting on with this project. I'm so pleased I just started doing it. And thank you for accompanying me through the journey. Now, whilst I was doing that, not wanting to waste a minute, I was filling the dishwasher. And if you've watched my dishwasher video just before Christmas, I think it was, where I had replaced our lovely old Bosch dishwasher with a replacement Bosch dishwasher because of my long-standing, decades-long customer loyalty to the brand Bosch and my belief that they make really outstanding, good quality, long-lasting domestic appliances. You will know that I was sadly disappointed. They'd greenwashed it. It is not very good at all. In fact, as the person responsible for filling and emptying dishwashers over the Christmas period, well, all year, but particularly Christmas, I was monitoring how many washes we did each day, and for every 3 washes I had to do an extra wash simply because I couldn't fit everything in. If I had done, it wouldn't have been washed properly. It's really disappointing, but it was lovely to know that I've got so many highly intelligent viewers. It's fantastic, who are so knowledgeable about so many things, right down to dishwasher systems and soap types. And it's absolutely brilliant. But to cut a long story short, if you're thinking about buying a dishwasher, don't buy a Bosch. If I'd known this then, I wouldn't have. I'd have gone, if I could have afforded it, I would have gone for Miele, who remain brilliant, beautifully engineered stuff. And if I couldn't afford that, because this was about 650 quid I think I spent in the end, because I thought, well, okay, let's go for a good quality one, which is sort of $750. I can't work it out. It wasn't worth it. So if you can't afford a Miele, because they are much more expensive, I would go for a cheap end one that is probably going to break after sort of 3 or 4 years. But who cares? The money you've saved, you can buy another cheaper one. Anyway, I'll stop talking about dishwashers and get some more stuff cut out. Actually, one more thing about dishwashers. I hate this. Every time I use this, I am filled with hate because it's greenwashed. So when you switch it on, it has a choice. Eco, e.g., you care about the planet, you want to save the whales, you want to save the environment, everything. Oh, it's so lovely and green. Auto, we at Bosch care about the environment. We want to preserve the world for our future generations. Or intensive means you hate the earth and you want to destroy it as quickly as possible. Intensive. That's the one I always have to use because that's the one that actually will clean it. These two don't touch the sides. So you have to press this 3 times to get it onto. It's absolutely ridiculous. And as always, where there's a dishwasher and there's pre-washing to be done, we have Ziggy, who takes it all very seriously. And as I think I mentioned in the past, I think it would be better, rather than having a Bosch dishwasher, just to put all the cutlery and everything else on the kitchen floor and let her do it. It would certainly be very, very clean. So the next layer is the 2mm thick black one to stop the LED, hopefully to stop the LEDs, the light shining through all the painted clear acrylic, which wouldn't be very helpful. Whilst that's cutting out, I'll show you something else I found in my bedroom. What could it be? I hear you cry. Oh, Sinclair. Look. Oh, the joy. Some of you may well remember these printers, which were revolutionary, and they'd plug in between at the back of the Spectrum and the memory pack, and they used silver paper, this metallized paper, and they had a stylus that would run across 1,000 folds, burning off the printed bits that you want. I can't find somewhere. I'll have a look and see if I can find any of the things that I printed on this. I found my sketchbook from the Art and Design Foundation course, not out of choice. I think it was the only picture I could find in the magazine of someone with a nice big head. But look, I've always been fascinated by how to represent images and things in computers. It's amazing. But I didn't have a scanner, so I had to work it all out. And then this is the silver printing paper with the program. Oh, the joy, and graphics. Very basic, but just experimenting with what you could do. Look at that, well, the effect it would have by changing different parameters and stuff. Oh joy, such lovely memories. I just couldn't throw that away or anything, I had to keep it safe. Oh, what a joy. Oh, and the little button, that's right, you'd press that. The things you remember when you wanted to advance the paper. So there's that, and there's this. And again, I had no idea what was in it. It's an international reel-to-reel to look at that. Oh, isn't that a joy? I don't know what era this is. What's these transistors? But it's just so lovely. Tape recorder. I just couldn't get rid of that. I will put it somewhere safe so that it's someone else's problem sometime in the future. So there's the black bit with some extra holes for M3 screws. That's right, countersunk ones, because that's going to glue on the front. I've made the black one about 1 millimetre larger all the way around, because it just, if you're going to have a gap or a change, make it obvious, don't try and hide it, and it gives it a nice little twiddly bit feature. So that's good. Now the next thing, I'll do anything else. The idea is, these are obviously the offcuts from the 3mm clear acrylic. I'm going to cut some of these out of the opaque white, because the idea is I'm going to sit them in there, glue them in. That's 2, this is 3, so there's an overhang of 1 millimetre, and then if you imagine this painted up, that will just be the bottom of, it'll appear in the bottom of the cutout. So that's the idea, so that'll then support these windows. Just before we get all gung-ho about getting these bits cut out, a little bit of experimentation. Here's the opaque white, and it's just running the normal sketch that cycles through the colours and stuff. It shows up really well. If you lift it too high, then yeah, you get colours along, but there's not room to do that, and once you can see the colours more distinctly, you see the dots, so that's okay, that would work. But that to me looks lovely. It's not leaking out, seeping out anywhere else, it's just within that strip, and that's great. So the next job is to, and obviously this is going to be used in a classroom that's going to be lit really well, properly, so I'm glad that I've got lots of fluorescent lights pointing at it and I can still see it clearly, and that's with the LEDs set to about 10 or 20 out of 255, so that's what, that's about under 10%, I think, something like that brightness, so that's good. Right, next job is to cut out the 5mm bit that's going to hide, actually enclose all the LEDs. Oh, this is very exciting. I'm really enjoying myself. I'm so pleased. Lovely. As we know, when cutting 5mm thick acrylic on here, on top of the honeycomb thing, which I've lifted out, always hoover, do the house cleaning beforehand, because there's enough laser left over to shoot through the 5mm acrylic and then set fire to anything under here. And look at all the sources of fire we have. Fuel everywhere. Look at acrylic fuel. Apparently it burns very, very well, and you can make rocket engines out of it. Anyway, I will get this cleaned up. I've been adding to this video for days, and it's getting longer and longer and longer, so I think this is the best time to stop. Thanks very much for watching. I will have another video out in a few days of the next part of this. Hope to see you then. Thanks again.